Hello, dear friends. Our subject is here Engineering Mathematics 3, and today's topic we are going to discuss case 3 or type 3 of shortcut method. Shortcut method is used to find the PI. Already discussed the general method and first two cases or first two types of shortcut methods. Now here we are going to discuss the type 3 or case 3 of shortcut method to find the PI. And this topic is from first unit LDE, linear differential equation with constant coefficients. So the type 3. When the function is f of x is equal to cos h x plus b or sin h x plus b, means hyperbolic cos function or hyperbolic sine function is there, where a and b are constants. The formula for PI is 1/5 of d square into hyperbolic sine function sin x plus b sin x plus b. Then in that case, to find the PI, we replace d square by a square. We replace d square by positive a square and not the term of d. We replace the term of d square here, like the trigonometric functions sine and cos. These are the hyperbolic functions here, sine and cos. And here in this case, we replace d square by positive a square. And so your PI is here 1/5 of a square into sin ax plus b. If phi of, and the condition is phi of a square must be non-zero. If your phi of a square is 0, then it is the case of failure. And if it is the case of failure, then to get the PI, you will multiply numerator by x, take the derivative of denominator. Derivative of denominator will be phi dash of your derivative of phi will be phi dash of that function of phi dash of d. And in that phi dash of d, you replace the terms of d square and not the terms of d by a square. And so the PI is in that case x upon phi dash of a square to sin of x plus b. Phi dash of condition again, phi dash of a square is no, it must be non-zero. If your phi dash of a square is 0, then it is again the case of failure, and you repeat the same procedure for to find the PI. And same result is there, same formula is there to find the PI when there is hyperbolic cos function, cos h x plus b. Same formula is there, means you replace d square by a square. Now the example here, solve d cube y by dx cube minus 4 dy by dx is equal to 2 cos 2x cos 2x. Here the first you reduce the differential equation. To reduce it, you use the substitution, put d by dx is equal to d, d by dx is equal to d, and so d square by dx square is d square, d cube by dx cube is d cube, and so your LHS side reduces to this d cube upon dx cube, its substitution is d cube, minus this 4 as it is, d by dx is d, so replace it by d. Now in both the terms that y is common, so you take it common here, is equal to RHS side as it is, 2 into cos function cos 2x. Here auxiliary equation is here, d cube minus 4d is equal to 0, because this is the reduced form of LD. Phi of d into y is equal to function of x. And so the auxiliary equation is here, d cube minus 4d is equal to 0. It is a cubic polynomial. Here we can take d common, so you take it common. D is common, so remaining term is d square minus 4 is equal to 0. So we have d is equal to 0, or d square minus 4 is 0, means the factors of this quadratic equation d square minus 4 is equal to 0. The factors a square minus b square form. This equation is in the form of a square minus b square, and the roots of a square minus b square is equal to 0, or a is equal to a minus b, a plus b. And so the factors are here: d is equal to +2, -2. And so total 3 factors: 0, 2, and -2. So these 3 factors are real numbers and they are distinct. So your complementary function in this case is c1 e raised to 0x plus c2 e raised to 2x plus c3 e raised to -2x. And now the pi, to find the pi, the formula is 1 upon pi of d into f of x. So 1 upon pi of d is here d cube minus 4d, and function is here 2 into cos 2x. Now to solve for this cos 2x hyperbolic cos function, we always replace d square by a square. The value of a, coefficient of x, is here 2. The square of 2 is 4. So replace that d square terms by a square, means d square by 4. If we replace that d square by 4, so this is d cube. So we can split d cube as d into d square, and the value of d square is 4. So this term will be 4d, and the second term is also 4d, and subtraction is there. So 4d minus 4d, 0, case of failure. So this 2 is constant, so write down as it is. It is a case of failure, so multiply numerator by x, take the derivative of denominator, d cube derivative is 3d square minus 4 into hyperbolic first function. Since 2 is a constant term, so write it as it is, x upon. Now solve for cos function, hyperbolic cos. Replace d square by a square. A square is here 4 because a is 2. The square of 2 is 4. So replace d square by 4. So 4 3s are 12. 12 minus 4, 8. So the term is x by 8 into cos 2x. And so your pi is here x upon 4, because 2 4s are 8. The simplification of the 2 by 8 is 1 by 4. So pi is x by 4 into cos 2x. So this is an example of hyperbolic function here. And this is the pi for the given function, hyperbolic cos function, and the general solution is y is equal to cf plus pi. And you write down the addition of complementary function and particular integral, then you will get the general solution. Here is your general solution for the given example. This is the example of hyperbolic function. These are the 2 examples. You try yourself, take it as a homework and try to solve the examples here of hyperbolic case type 3. Now type 4 or case 4 of shortcut method to find the pi. Now what is type 4 or case 4? When the function is in the form of x raised to m, means a polynomial function is there. Now when the polynomial function is there, then how to find the pi? You remember the formula, you revise the formula here. 1 plus x to the power n. The formula is 1 plus nx, n into x, plus n into n minus 1 upon 2 factorial into x square, plus n into n minus 1 into n minus 2 upon 3 factorial into x cube, plus and so on up to x raised to n. Second is 1 upon 1 plus x. The series for 1 upon 1 plus x is 1 minus x plus x square minus x cube, and so on. The third series is 1 upon 1 minus x is equal to 1 plus x square plus x cube, and so on. Now the example to find the pi when your function is exponential function. See the example. Solve 1 plus d into y is equal to x cube. Here auxiliary equation is 1 plus d is equal to 0, because the example is the reduced form of LD. Phi of d into y is equal to f of x. So your phi of d is 1 plus d. Equate it equal to 0. You will get auxiliary equation, and so the value of d is here -1, because it is a linear term, linear equation, and the root is -1. So complementary function is c1 e raised to -x here. Now the pi, the formula is 1 upon phi of d into f of x. 1 upon phi of d is here 1 plus d into f of x is here x cube. x cube. So now to find the pi of exponential function, you always try to reduce your denominator term phi of d in either form, either 1 plus x form or 1 minus x form, so that you can use the series for 1 upon 1 plus x or 1 upon 1 minus x. Now the term is here 1 upon 1 plus d. So it is this phi of d, 1 plus d is in this form 1 plus x. So you can use this series of 1 upon 1 plus x here, and you just replace the term of x here in this series by d. So you have to write only d here in this series because your term is 1 plus d. And so the series is here for d, 1 minus d plus d square minus d cube and so on. And your function is x cube here, f of x. Now, how many terms of d we have to count here? See, the degree of this polynomial function is 3. So you will get only 3 non-zero derivatives of x cube. From fourth derivative, you will get the value 0 because the first derivative of x cube is 3x square, second derivative is 6x, third derivative is 6, and fourth derivative is 0 of x cube. You know that n plus 1th derivative of x raised to n is always 0. And so you count the terms of d up to d cube only. The degree of this polynomial is 3, so you count the terms of d up to d cube only. And now you solve this bracket term for this x cube. This x cube into 1, x is x cube minus d. D means derivative. Capital D means always d by dx, derivative. D of x cube means derivative of x cube. First derivative is 3x square. D square means second derivative plus first derivative of x cube is 3x square and next derivative is 6x. So d square of x cube is 6x minus sign minus d cube means third derivative of x cube is 6. So you write here 6. D raised to 4 into x cube. Fourth derivative of x cube is 0. So no need to count the terms from d raised to 4. You just count the terms up to d cube because the degree of polynomial is 3. And so this is the pi, x cube minus 3x square plus 6x minus 6. And so the general solution is here, y is equal to cf plus pi. And you just add complementary function and particular integral, you will get the general solution. Now, the next example is here. Next example, 1 minus d square into y is equal to x raised to 4 plus 1. It is the reduced form of LDE. Phi of d into y is equal to f of x. So your auxiliary equation is 1 minus d square is equal to 0. So the factors for this quadratic equation are here. D is equal to plus 1 minus 1, because if we shift this minus d square here, it will be plus. So d square is equal to 1 means d is plus minus 1. So the complementary function is c1 e raised to x plus c2 e raised to minus x, because these are two roots and they both are real and distinct. And so the pi is here. Pi is here 1 upon pi of d into f of x, 1 upon 1 minus d square into x raised to 4 plus 1. And so you use here the series 1 upon 1 minus x. 1 upon 1 minus x series is 1 plus d square plus d square square plus d square whole cube and so on into x raised to 4 plus 1. Now solve for this x raised to 4 plus 1. The degree of x raised to 4 plus 1 is 4. So you count the terms up to d raised to 4. It is 1 into x raised to 4 plus 1 is x raised to 4 plus 1 plus d square, second derivative of x raised to 4, 12x square plus d square square is d raised to 4. Fourth derivative of x raised to 4 is 4 factorial, means 24. So right here 24. D square cube, d square raised to 3 means d raised to 6. Sixth derivative of this function is 0. So you count the terms up to d raised to 4 up to this. Simplify it. And the term is x raised to 4 plus 12x square plus 25. And so the general solution is y is equal to ca plus bi. So this is the answer. So this is the case type 4 example, and this is one more example. You try to solve this example. Take it as a homework. Here the case 4 is over. Now discuss today case 3 and case 4. Thank you. Thank you very much.